Before we transition into chapter 2 and talk about linear graphs and equations, we're going to do a short mini unit for the week that talks about different types of graphs, what those graphs look like, and how we can describe different graphs. Algebra 2, a lot of it is looking at different types of equations and different types of graphs and comparing them and looking at what they can do for us. So this mini unit is going to look at different types of graphs and how in general we can describe graphs. These notes that we're going to do, we're going to fill in most of it, and then we're going to fill in the rest of it in class. So just follow along with me, fill in the parts that I tell you to fill in, and then like I said, we'll finish them up in class. So the first way that we can describe graphs is by looking at the domain and the range. And these should be words that you have heard before. The domain is the set of all inputs or x-coordinate. Now there's three different words that we can use to represent the domain, and the first is the domain. The domain can also be referred to as our input. So what are we putting into the function? That would be our domain. And the other way we represent domain is x-coordinates. So whenever they ask for the domain, we're looking at the x-coordinates. Now the range is the set of all outputs, or the y-coordinates. And again, there's three words we can use to represent the range. So it's the range or the outputs or the y-coordinates. So whenever we have a graph or an equation, we can look at the domain and the range, or the inputs and the outputs. Now there's three different ways that we can represent or write domain and range. The first is set notation. And with set notation, we're going to use little squiggly brackets. So it's the list of all the inputs or the outputs, depending on which we're looking for, the domain or the range, inside squiggly brackets. So for example, the domain could be written as 1, 2, 3, and 5. So that just tells us that the domain is 1, 2, 3, and 5. We can also do the same for the range. So the range or outputs are 2 and 3. So again, set notation, we're looking at squiggly brackets and we're just listing the domain and the range. This is usually used if we're just given specific points and we don't have a full graph that is connected or continuous. The next is algebraic notation, and this is using equality or inequality symbols and variables to describe the domain and range. As we know, the domain is talking about our x values, so we'll use x whenever we refer to the domain, and we will use y whenever we refer to the range. So again, our inequality symbols would be less than or equal to, greater than or equal to, is equal to, or is not equal to. So some examples would be y is greater than 5. So that's talking about the domain because it's y, and it's telling us that the domain is greater than 5. We can also use compound inequalities. So if our domain is from -2 to infinity, we can write it as -2 is less than or equal to x is less than infinity. We could also write this as x is greater than or equal to -2. And we'll look at some more examples so that this will make a little bit more sense as well. And the last is interval notation. And this is for continuous sections of the graph. We use either brackets or parentheses. So for continuous sections of the graph, you're going to write the starting and ending points. And they're going to be separated by a comma. So you're going to think of it like writing out a coordinate, but only you're either using brackets or parentheses. So we need to distinguish whether you're going to use brackets or parentheses. So we use parentheses if the point is not included or not contained in the domain or range. D/R just means domain or range. So this would be our open circles, or if we have negative infinity or positive infinity. We will use brackets if the point is contained in the domain or range. So it is included. So again, that would be like our closed circles. Now tomorrow in class, we're going to put a flip chart at the bottom of this page so that we can visually see the domain and range. So again, we're going to turn the page to the next page of notes. So domain and range is a way that we can describe functions. And a function is a relation in which for every input, there's exactly one output. And another way to think about this is there's no repeating x values. So some characteristics that we are going to look at. We're going to be looking at graphs of functions. So if a relation passes the vertical line test, it is a function. And we're going to talk about what that is in just a second. So again, if a relation passes the vertical line test, it is a function. So it's considered passing if when we look at the graph, every vertical line intersects the graph once. And it's going to fail if each line intersects the graph more than once. So if we think about the graph of a function, if we draw multiple different vertical lines through the graph, it should only intersect once per line. If it hits the graph more than once, then that's when it's going to fail and it's not considered a function. So some examples of functions. The first, we can write it out. So we have coordinates 1, 2, 4, 7, and 3, 9. This is going to be a function because, again, the x values are not repeating. So notice they're all different numbers, so therefore it is a function. We have an input and output diagram. Again, think of the input as your domain, the output as your range. So if we have the numbers 2, 4, and 7, and 2 is going to go with 3, 4 is going to go with 0, and 7 is going to go with 5. Notice that each of the x's has a different output, or there's only one input for every output. So that makes it a function. Some non-examples, or examples that are not functions, would be 1, 2, 1, 3, and 2, 4. In this example, if we look again at the domain or the x values, we have 1, 1, and 2. So notice that we are repeating our 1, so therefore it's not a function. If we have an input and output table for this one, let's say 2 and 4 are input, and the output is 3, 5, and 7. 2 is going to go with 3, 2 is also going to go with 5, and 4 is going to go with 7. So notice our input of 2 goes with 2 different outputs. So therefore our domain, our 2 value is repeating, so it's not a function. There are multiple ways to represent functions. We can do ordered pairs or coordinates. We can do the mapping diagram, the input-output diagram. We can write functions as tables, and we can represent functions as graphs. So for the first one, ordered pair, I'm going to give you a group of coordinates. So 0, -4, -2, 3, 1, 3, and 2, 0. So again, a function can be represented as an ordered pair. Now again, we can tell that this is a function because if we look at the x values or the domain, we see that they're not repeating. So this is a function. Now since it's a function, we can look at the domain and range. So our domain, again, we're just going to list our x values. We usually list them from least to greatest. So we have -2, 0, 1, and 2. And the range in this case is -4, 0, and 3. Now notice we have 3 listed twice. When we're listing the domain and range, it's not necessary to list the same number twice. Now we can also represent this function with an input and output diagram. So again, our domain is our input, so we can list those, -2, 0, 1, and 2. Our output is -4, 0, and 3. Now -2 is paired with 3, so we're going to draw an arrow to 3. 0 is paired with -4, and I'm just looking at the ordered pairs, and that's how I know which is with which. 1 is paired with 3, and 2 is paired with 0. So again, just another representation of the function that we were given. The next is a table. So we're going to list our x and y values in a table. So again, our x values are -2, 0, 1, and 2. So the y value that goes with -2, again, is 3. The y value that goes with 0 is -4. The y value that goes with 1 is 3. And the y value that goes with 2 is 0. And then lastly, we can represent functions on graphs. So we can just graph these ordered pairs. So we have 0, -4. Remember, to graph, we first go left and right, or x and y. So 0 means we're not going to go anywhere. -4 means we're going to go down 4. And that's where we're going to put our point. The next one is -2, 3. So we're going to go to the left 2 and up 3. That's going to be our next point. The next one is 1, 3. So go over 1 and up 3. And lastly, we have 2, 0. So we're going to go over 2 and go up 0. So again, a graph can represent a function as well. The last part of notes that we're going to cover in this video is the very last page. If you notice, there are a bunch of graphs on this last page. And what you're going to do is you're going to cut out all these graphs, and we're going to glue them in the correct columns on the function and not function page on page 3 of your notes. So what I want to do is look at one of these examples and determine whether it's a function or not. So I want to look at letter C. And we talked about the vertical line test. And basically what that says is we're going to draw vertical lines through our function. So the first line that I drew, notice that it hits the function at this point here, and it also hits the function in a second point as well. If you look at the second line, same thing. It hits it in 2 different places. Now if you remember, that means that it fails the vertical line test, so this is not a function. So when you cut this one out, it's going to go in the non-function column. If we look at H, again, if we draw vertical lines anywhere in our graph, remember vertical lines are up and down. Then if we look at where it crosses our graph, so my first line, it only hits at this point. For my second line, it only hits at that point. So every vertical line that I draw, it's only going to hit the graph at one point. So this is a function. So again, I want you to look at each of these examples, and I want you to place them in the columns where you think they belong. And then tomorrow in class, we'll talk about where they belong, and then we'll also look at the domain and range of each of these.